Okay, so the second talk is about standardizing the trace points for the PELT load tracking algorithm. Several people already showed some nice Lisa graphs where they tried to explain to us why certain task placement or load balance situation happened. And all those pictures, more or less, they are based on proprietary trace points we use in our product code line and in our Lisa tooling. And just for the sake of that you can essentially share those things with the customers when they sometimes deploy like mainline code. It would be nice to have them in mainline as well. We know that, I mean, it's opening up a can of worms if you allow too many trace points. Like people say, I have this very important functionality. I want to know, for instance, when the system is in overutilized state or not. So for this, you need another trace point. So it's probably a never-ending story when you want to control or you want to know what's really going on in the system. But I think we reached a point, or like also for the shared util problem, from where the shared util governor behaves weirdly, and we think that's due to the load balance, to the utilization signal of the CFS run queue. If we would have a standardized way to essentially establish that this is really the case, then debugging those things or creating functionality which prevents it is much easier to do if you do it in a shared way, like between people with different areas of expertise, for instance. So this talk is about those trace points for the PELT signals, short introduction, then I talk about the design, and I will give an example how we can use this for one of the existing problems, that's the propagating stuff, the reflect stuff you just got in last year, where we essentially use those trace points to establish that with your patch set, the behavior is much more appreciated from us. So this is all about creating trace events for load and utilization values for all those different scheduler bricks we mentioned already. CFS run queues, shed entities, which can be tasks or shed entities representing task groups, and the actual task itself. All of them have kind of PELT signals attached to them. PELT, it's per entity load tracking. Per entity is because we build up the load signal from the smallest entity like the task, and then we aggregate it to CFS run queues, or like we saw before in the talk, to even shed groups or shed domains. And where can this be helpful? I already mentioned this. If we want to debug task placement decisions, because especially with EAS, we get bombarded with a lot of trace stat files from customers, and they ask us specifically why one of their test tasks is essentially not ending up on CPU 0, but on CPU 2 at this moment. And then for us, it would be nice if we can have those signals to tell them what's really going on with the scheduler underneath the hood. Another thing is OPP selection, the talk we had this morning. So I'm just mentioning those use cases. We have the CPU freak stuff here, which is very recent. This is the reflect stuff when we had to deal with the PELT signals, not only on a flat hierarchy of CFS run queues representing CPUs and tasks, but when we deal with multi-level task groups, like for instance system D on a server system. There was also something very crazy here. You remember this stuff where we essentially put utilization or load signals on CFS run queues or shed entities of CPUs which were not even there, because we were using the possible CPU mask and not the online CPU mask. So with all of those things, it was very hard to figure out what's going on. And if we would have those trace events, that would make this kind of debugging easier. This is just like to illustrate how a system look like. I'm mentioning here those bricks, CFS run queues, task groups, shed entities. Shed entity can represent a task or can represent a task group on the next lower level of the task group hierarchy. So each task group has n CFS run queues and n chat entities, each of them representing one CPU of the system. And when we talk about, for instance, the input signal for the scheduler stuff, it's derived from this run queue here per CPU. So when we are on the root task groups. Obviously, if there is no fair group scheduling involved, then you don't have the system. You only have those root CFS run queues. You don't have this, and you only have tasks to deal with. So
and life is good.
It's much better, yeah. Much more sane. From this picture, I just wanted to mention some of the design requirements, regardless of the configuration of the kernel related to, also we have outer groups. Not to forget outer groups, they are a special breed of groups.
Linux is a magic hack.
But anyway, people are allowed to essentially come up with a system where they enable fair group scheduling or not. There's SMP, but all of what we talk about here is only available if there's SMP support. Another requirement is for post-processing, like Lisa, the tools, we need the information of those key and value pairs when we talk about load and utilization in all of those trace events, regardless of the configuration of the kernel. You can imagine if we put, for instance, the information which task groups we run on, then the task group is characterized by a path or an ID. And even if we don't have task groups, we have to have those keys with an invalid value in the trace. Otherwise, I think we will confuse the tooling. Not sure about this.
It's me that is you're changing the template of our trace events depending on which feature are made.
But how does the tool figure out?
Well, the tool can be adapted to don't care about it, but you have an API that is depending on how you compile the kernel, which maybe is not really.
Okay. But I think the next point is much more important, that we don't want to like expose too much information of the underlying load balance algorithm itself. So more than just exposing one load and one utilization value per brick, per CFS brick is probably too much. And all this stuff has to be obviously minimal invasive to the actual scheduler code. And during the review of the patch set, I figured out that we should not expose those accessor functions of the private classes because it opens up like for other weird things to happen. But there's a way to still have those trace events without this being in the public header file. So the design of the CFS run queue trace probes, we map load and utilization to runnable load average and average util average for this one. This one is, like we have talked about in the previous talk, this is used in the load balance code, not necessarily in the code where we establish the hierarchical influence of the task when it runs in a task group. There we use already average, load average, but like maybe we can switch to.
And the other point is that the average, load average is used, for example, for the share between group entity.
Exactly.
So I think it's worth having that. Because in fact, load average, the runnable load average, it's only a set part of the load average.
True.
So,
but if we can, like there was, I think you mentioned this, that maybe we can use the average load average also for load, so we can get rid of the runnable thing. Then this will become easy and map to only.
To be honest, I'm more using.
So I don't think we want to use. Or you want to get rid of util, or you want to get rid of
runnable.
Runnable.
So runnable works good for the distribution of shares between CPUs. I don't see util working here.
No, the point of runnable is that it's moving quite a lot. I mean, I have something similar. Most of the time I'm disabling runnable load average because it's just a big noise compared to the load average, which is more stable and give you how the CPU or group of CPU is loaded. That's my point. And normally this is a part of the load average.
True.
So I was just wondering if it would be better to have the average load average instead of the runnable load average.
Yeah. Okay.
In the metric, in the trace event.
Okay, I agree.
Okay. But like the layout of those trace events, they would look like this. So we have those two values, which then we can use for post-processing. And to identify, the only remaining bit is to identify the CFS run queue. So if it's a root task group or a normal task group and auto group, we have to probably use the path information. There's always this crazy CSS ID, but it's very hard for somebody debugging this to know that CSS
Can
ID.
you actually figure out the CSS ID of the secrets?
Yeah.
So that is exposed somewhere.
It's part of the task group data structure. The task group data structure has this.
But if I'm in user space with my dash prompt, how do I find the CSS ID of the?
No, not in user space.
See, that's the problem.
It's not in broker C groups, it's the AD that is reported.
You mean, no, it's just a summary, right?
Yeah, no, it's another.
No.
Because then it becomes very hard for tools to map back to the actual path.
Mm.
If that information is not available, then.
Yeah, I was also convinced that the path is more important than the ID itself. Even though you could identify if you know what ID number 6 means, actually.
Yeah, but if it's not exposed, you can't know what 6 is.
Exactly.
One of the reasons that the idea was that you can tell it's not a good one. So you see it. I mean, I don't even need the whole thing.
But that's the slash. I mean, it's also one character. If it's one character path,
Yeah,
you're right.
but I mean, you don't really want to do that. You don't really want to search the path and then string whatever.
You can do a string length. If the string length of the path is 1.
It's all post-processing.
Yeah.
And the good point of having it coded in the trace event is that if you collect a trace and you send out a trace to someone else that doesn't have access to the user space, maybe it makes it difficult to the mapping back the AD. Or in that case, you already know.
Well, supposedly you can't even map it if you have access to the user space, because the CSS ID is not exposed at all.
Yeah, it's not sort of. Is the other names always fixed like that? Could you change the name? Is the name of the folder?
Well, yeah, you can do meter in CQFS and then move the dash around.
Yeah, and then, but that's not that folder. So it's folder groups in it. It's sort of string whatever in the name.
Yeah, it always has.
Yeah.
And then a number.
You can't go in and call that regular task group auto group -1.
I don't know.
Because you can do that.
Never tried.
We have a theoretical problem. I don't know.
Yeah. Never tried.
I wouldn't be surprised.
No, me neither.
Okay, so the other thing is like if group tagging is not enabled, we still print out the path as nil.
Why not just dumping root, like if it's in the root just slash?
That's another alternative, yeah. But we also have.
Maybe in this case, you know that shared group fail was not enabled in that system. In the other case, you
It
can.
wouldn't be a mistake actually,
But it's more generic.
okay. But like also like the shared entities are much more complicated because they represent not only tasks but also task groups. So the mapping is easy because there is no runnable. Load utilization is easy, but here we have to deal with task. Obviously the path is 0, and then we have to specify the name and the PIT. For task groups, it becomes a path, like for the CFS run queue, and this other information has to be somehow specified as not valid. And there are auto groups and config flag group, or without config flag group. It's essentially the same like with the.
Why do you need the curve?
You can. You can.
I don't need. No, the ID, the PIT would be sufficient. But it's. I mean, if the task is already gone, then and you have a tracer from somebody else, it's easier to discuss, like when you have the name of the task, probably. It's not very important. Like also the other trace events dealing with task in chat.h, they print out comment and pit.
Yeah, colon pit. I think we all do.
And then there's the task group itself, which has only load signal, and it essentially follows the layout of those other two bricks. Then there's the question, where do we put those trace events? Because one of the strengths of a standardized approach would be that everybody essentially get the same kind of trace dynamic when they do PELT trace events. And when we did this reflect stuff, I forgot to put it, for instance, in propagate, and the signals, they were not showing the behavior we were after. So for CFS run queue and chat entities, we have to put it somewhere in update load average, because there is where the magic happens for the PELT signals. CFS run queues, they can add or we can delete a certain task or chat entity for task groups when we attach the entity or detach. So I have to put probes in there, and then the new stuff where we propagate load or utilization down from task group hierarchy towards the root task group.
And why not using update load average instead of underscore update load average? Because right now, how it's done, most of the time, before doing anything, we are syncing the run queue and the scale entity with the load average, which is called almost everywhere, except maybe for the attach and detach. So you have one sync point, which is update load average.
And update load average is only called for CFS run queues, or it's also?
No, it's called also for scale entity, but I mean it's a sync point for everything. So you're pretty sure that at that point you can trace both CFSRQ and scale entity because everything is in sync at that time. And especially maybe you can.
That's what we DK before we have stuff. Yeah.
And maybe that can help you to prevent some spurious call of the update, because the update, the underscore update load average can sometimes be called twice without any good reason, just to be sure. Just because
when you say twice, I mean we have some if conditions like testing the last update time, and then we bail out before. So.
Yeah, but
Okay. Point taken. I have to look into this. The question for chat entities is also, I think it came up yesterday, those init functions where we essentially init the load for chat entity, and then there's another function where we init the utilization based on the remaining capacity of a CFS run queue. I'm not sure if it would be nice to essentially put trace events there as well, so to see when a task essentially gets created, then what's the initial value of load or utilization. It can help in certain debugging scenarios.
Maybe the positivity should be that, because in the init entity we may both.
I think this one deals with utilization, the other one deals with load. So we set load to 1024.
Yeah, but I mean, for the post-init entity, the value can be different. The utilization average can be different. Whereas when we initialize it, when
we know it's
initialized, it's one value. There is no smart way to compute the initial value.
But
so we know the value.
Like with this functionality, are we sure that this is essentially giving us something like giving the initial utilization value depending on the remaining capacity of the CPU?
Yeah. But for this one, it makes sense. For the post, it makes sense.
Don't you have right after running queue where you still generate an event because of the update, whatever, which is probably exactly the same initial value?
No, I haven't put something here so far.
So shouldn't trace version entities.
We'll probably attach that somewhere just after. That's the first thing that we're going to do, attach.
And the attach of the shed entity is not only affecting the CFS run queue, it's also affecting the shed entity itself. Do we do like an update for the shed entity when we attach? I can have a look.
Yes, we are attaching.
Okay, so the remaining bit is just showing an example. I have this is like testing Marston's patch set when when you fix the propagation stuff down the task hierarchy. So the task I'm using is a periodic one. The task group is like a third level task group. The iterator of the test case is like to switch to force the task to jump from CPU 1 to CPU 2 after 20 periods. And in the trace you see a trace 0 without a patch set and trace 1 with a patch set, just showing the effect of this patch set in one of those IPython notebooks. So in this IPython notebook, I'm not using deflib, so I just use some pre-existing trace.dat files. The RTUp code is created by this JSON file for RTUp. So you see two phases of the task, CPU groups, and here we switch from CPU 1 to 0. And when I go down, this is like the kernel shark thing we have in the IPython notebooks. You see the task is switching from one CPU to another, CPU 1 and 2. I use CPU 1 and 2 because both of them on the Juno systems are big CPUs, so capacity is 1024. That means when I calibrate RTUp, I get exactly the time values I was calibrating. And so this is like the, maybe I can go back to the, so this is like the test, the picture of this test case. So the task is essentially enqueued here on CPU 1 and CPU 2, and then we trace all those load signals of the shed entities, the CFS run queues on the different ID values. The version I'm using in the IPython notebook is not using the path, it's using the ID. And you have the shed entities representing the actual task group level, which then gets enqueued in the next lower level of the shed entity. And this is like the root one, which drives, for instance, like shed util. So on the highest CFS run queue, this is utilization. The value between the green is a trace number 1 without the patch set. The blue one is with the patch set. All looks the same. It's all good. But there's no propagation needed because we just introduced the task into the highest CFS run queue. But if you go further, like one level down, you see the effect of without the test, the patch set, you essentially have the signal has to ramp up. So, and with the patch set, we essentially have this. Since it's a 50% task, we have the utilization value established at 512. And this goes further down, and obviously introduce some problems when we derive the shed util governor from it, or we essentially use this signal, the CPU util signal, also for the ES load balancing in the wake-up part. Yeah, so with standardized trace events, we can always use them in Lisa notebooks, and the good thing would be to, like, our customers can essentially share those trace events or trace DAC files with us, and then we can run them via our Lisa notebooks. That's the aim of the whole effort.
We can also go for the regression testing in Mainline.
Yeah.
Customer stuff.
So last slide, I'm just listing some of the pros and cons. This is essentially all what I said. Obviously, we don't want to put in too many trace events, but I'm convinced that this health stuff is important enough to deserve some small trace events.
So yesterday we mentioned that we want some PELT-like tracking for real-time and deadline as well, simply so we can compensate for that pattern in CFS. Would these trace points also be able to cover that?
Right now they are like...
I mean, the code does not exist, but are they already are they suitable? Would that
Not in the current form, because we were talking about those accessor functions, which are like shared entities, CFS run queues. They are very specific to the CFS shared class. So we have to find it. Obviously, those.
maybe we can put the trace points in the real time. But so the trace points themselves, is their format suitable to also use in that scenario?
You probably need a new way to.
Or do we then need more trace points?
As soon as we don't have task groups in Deadline, right?
Not yet.
But you have something which is like a shared entity, probably shared entity DL.
Yeah. I guess utilization might be just the utilization of the task, the bandwidth associated to the task, and load might be the same in that case. So yeah. So,
In your pass, you have a pass where you have slash you start by CFS slash or RT slash to say that it's the signal linked to CFS task. Just to make the difference with one single trace, you can say if it's for RT, CFS, at least CFS or RT, if we have some PELT signal for RT and we want to enable the trace as well.
But is the aim also to have this PELT signal then also? If you would have task groups, you also want to have it per task groups or just flat?
I'd say it's flat. I mean, you still have. I mean, the group will have the utilization of the whole group, so we still have shared.
Yeah, if we want to have those trace events like usable for all shared classes, we can find a way to distinguish them.
You can just add a class key.
Yeah.
Well,
Yeah.
RT or CFS.
Also.
And then the parameters. I don't know if. In Deadline, you have much richer information than just utilization. But it can make sense to report.
Yeah, but I guess, I mean, since we don't want to change the format of the thing, I guess that's still meaningful for Deadline as well.
As long as we don't have them like the Deadline or stuff, then we can still mimic those CFS accessors in the trace file, or should it be also like abstracted to deal with more? I mean, it's very hard to deal for something which is not there yet.
So yesterday people wanted to add stuff.
Yeah, some PELT signal for the RT part. The goal would be to reuse the same function.
Okay.
So we need to make the difference just to be sure to not mix.
Okay.
CPU 0, what is RT?
So maybe I should prepare those trace events to be able to cope with the.
Yeah, with several.
Was it your proposal or who?
Sorry?
Did you propose those RT parts?
Yeah.
Yeah. So do you have any code?
I have some code. I can send. I can send it by myself.
Right. So that then people can more easily see what things look like.
Because the goal is to reuse the same function.
Okay. So yeah, that's my last slide, and I think. Are there any more questions to trace events related to PELT?
I think it's fine. I'm maintaining my own bunch of trace events, so if I can have some in the mainline, that's fine.
Okay.
I mean, that's I think.
I think there's a whole number of similar patches out there.
Yeah.
Task group is not